Okay, hi Rob. Thanks for joining our booth today. And this is I'm Patrick Dunne. I'm an engineer here at 3D Systems. 3D Systems is the company that invented 3D printing. We're the founding company of the whole 3D printing industry. And today at our booth at Rapid, we are showcasing some novel technologies at the front line of innovation that have not been seen before. And one of those products is the next generation of stereolithography. Whereas traditional stereolithography utilizes a laser in order to solidify resin, this particular system utilizes a projector. And it doesn't have a membrane. So one of the key benefits of this technology is that it takes the perfection and consistency that you get with stereolithography and it combines it with the productivity that you get with pixel.
Gotcha.
And the types of applications that are enabled by this platform include low volume, production grade plastic components. So this part is produced in a specialty resin that was developed for the automotive industry that has environmental stabilization. And that's what's required for production plastics. For prototyping, you don't need a plastic that lasts very long. You just got to test something. But if you want to make something that goes into a production environment, it's got to be resistant to ultraviolet from the sun. It's got to be resistant to water, heat, cold. It's got to have what's called life cycle environmental stability. And we test these plastics, out to 8 years, indoor, outdoor, accelerated environmental testing. We have a whole range of different plastics, from gray opaque plastics, black plastics, white UV stabilized plastics. If you put this in sunlight, it will not change color, whereas traditional prototyping plastics will tend to discolor over time. This does not change color, which is super interesting. Now, apply from low volume plastic part production, which you see in automotive components, aerospace, interior trim, electronic connectors, consumer electronics, a whole bunch of different products. We can also take specialty resins that are optimized for investment casting, and using advanced software, we can 3D print those parts in formats that are 90% air. And this is an example of a sacrificial investment casting pattern. So you can take a CAD file, print a high precision pattern with no tooling, and then give this to an investment casting foundry. They'll dip this in a ceramic slurry, dry the slurry, burn out the sacrificial pattern, and then into the empty space they will pour metal. And so it could be stainless steel, could be aluminum, could be magnesium, whatever alloy you want.
Okay.
So you can go from a CAD file to a complex high-performance metal component using a state-of-the-art 3D printing plastic printer.
Great.
Okay.